Good afternoon and welcome to Beyond the Forecast. We start with a live look at the Niagara Falls camera right now. That is a balloon ride, I believe, that people can go on, and honestly, it is a pretty perfect day for it. I mean, you see those blue skies. Temperatures are really comfortable right now in the 70s. We'll be pushing up into the 80s. I don't want to spoil too much of Patrick's forecast, but I was just outside. It is absolutely gorgeous. Now I'm stuck in the studio, but Patrick Hammer is out in the Hamburg Bureau enjoying all of that sunshine. What's it like where you are, Patrick?
Hey, Lauren, I think we're onto something here. This has got to be the third Monday in a row where you and I have been discussing this, and the weather's been just like this. Spectacular. Seriously, this is probably, the start of our third week of consecutive nice weather. Now, of course, over the weekend, we had a little rain Saturday morning. We had all that wind on Saturday, man. And then that thunderstorm that came over at about 10:30. Then the weather got back to beautiful again yesterday, and here we are starting a new week with pretty much a cloudless sky once again here in Hamburg, where the sun is shining here just like it is across all of Western New York. And we're going to take a look forward. This week, though, starting off very nice, will feel a little different, though, than last week for a couple reasons. A, we think it's going to get muggier around here, and there will be some storm chances as well. So let's dive into it, take a look at the forecast, and talk about where we go from here first. This is kind of our topics. The weather headlines: sunny and warm today with temperatures into the low 80s. Tomorrow, we make a run at our warmest day of the year. We're going to get into the upper 80s. There is some thunderstorm chances tomorrow afternoon, and especially, I believe, tomorrow night. And then on Wednesday morning is kind of the time period we think we have some rain chances. It will also be humid. And looking ahead for the rest of the week, warm and humid conditions and thunderstorm chances kind of each and every day. Not all day, but tomorrow it's late. Wednesday it's early. And then Thursday it looks like some afternoon thunder showers. And Friday, some midday or early afternoon showers before drier weather works in for Saturday. More on that, though, to come. All right. Currently, we're in the 70s, and our humidity levels are in check. We've got dew points basically in the 50s still. That is very comfortable, and I think that is going to be, let's see, our dew point. Our dew point's currently 59, so we're getting close to 60. 60, when you look at dew points, is kind of the demarcation between comfortable and like, I kind of feel that. It's getting a little muggy. And that's what dew points in the 60s will do for you. And that's where I think we're going this week, and maybe even flirting with a 70-degree dew point later on this week. But temperatures today are in the 70s, and it still is on the comfortable side. So for today, 83 under sunny skies tonight, partly cloudy, and because it's getting more humid, it will not cool down as readily. So tomorrow morning, it won't be, we've had some cool mornings lately. Even this morning, we were into the 50s. That will not be the case for the rest of the week, as lows will be in the 60s, even close to 70 on certain mornings. Tomorrow at 87 with the threat of a few thunder showers. Now, rain chances, looking out the next 7 days, this looks different than it did last week when we only had like one day with a chance of rain, and that was we had pegged for Saturday. This looks like more active, where there are thunderstorm chances each and every day. And there's nothing terribly widespread expected, but you can see we're into a little more of a typical summer-like weather pattern when you see kind of a 40 to 50% chance each and every day. The weather pattern is going to be kind of in a, despite there being some thunderstorms, the day-to-day change is not going to be that great. So what I wanted to quickly get into is weather patterns that we were in certainly last week and we're kind of in this week, and that is when the atmosphere gets blocked up and things stall. And there's a couple of weather patterns that we really look at that are hard to predict sometimes, and when they lock in, they really lock in. And we'll get into exactly what these blocking patterns, as we call. So what I'm showing you here is a typical jet stream, okay? This is the upper level winds at about 18 to 30,000 feet. They generally move west to east. And along the jet stream travels areas of low pressure and cold fronts and warm fronts, and storms enter off in the west coast and then leave on the east coast or something like that, dipping to the north and south a bit. But that is a typical flow. Now, there are times when the jet stream becomes very amplified, okay, where you see a big dip and then a big ridge followed by a big dip. Think of taking a hose or a piece of rope strewn out over, let's say, your lawn, and you fling that rope, and if you raise your hand up and down really quickly, that rope will start to undulate as it goes down. Same thing happens with the jet stream. And when you have two dips with a ridge in the center, we call that an omega block. That is an atmospheric situation where the atmosphere is blocked up. Not much changes. Everything's kind of stops. Those two lows lock in, the ridge in the middle locks in, and that jet stream pattern resembles the Greek letter omega, which is why it gets its name. And in the wintertime, it could lead to pronounced cold spells and pronounced storminess in those dips or areas of low pressure. In the summertime, you can get real intense heat where that ridge sets up. That was the case last week in Canada, and we're getting kind of a version of that omega block this week as well, where there's going to be a lot of hot air in the center part of the country, unsettled across the west, and the weather pattern kind of locked in here with a very little day-to-day change. But the difference this time is we'll have a little moisture to work with, which is why humidity is going to kick in and maybe some thunderstorm chances. Okay, one more block in the atmosphere I wanted to show you. This is a different kind of block where there's an area of high pressure over an area of low pressure in the upper atmosphere. The jet stream tends to split around those, and a southern branch and a northern branch. And once again, weather systems fail to move across the country very quickly at all, or at times very slowly. This is called a Rex block. When these set up, it makes forecasting a challenge because weather systems kind of stop moving or are very little change. So in the wintertime, these can lead to stagnant weather, and in the summer, these also can lead to extreme heat events sometimes, especially under that ridge of high pressure. Okay, so we're gonna see kind of an omega block pattern this week, much like we did last week. All right, what you do see here on the satellite view is, again, a cloudless sky. Surface high pressure is keeping things relatively quiet, and a cloudless sky, much like we saw a few days last week. And looking out farther to the west, though, there is a little weak spin in the atmosphere near Missouri, and that's going to head our way despite the upper level winds. It's going to kind of slowly drift in our direction and add some moisture to the atmosphere and increase our thunderstorm chances in the days ahead. And watch, you'll see in this animation here, that high slides off to the south and east. Wrapping around that high is more of a southerly wind, thus a direction that produces more humidity around here. And that's why you're going to start to feel it even this afternoon a bit, as dew points may climb into the low 60s. We're certainly going to get there tomorrow and the rest of the week. The forecast for today in terms of daytime highs are generally in the low 80s with sunshine. Tonight, we're going to see overnight lows in the 60s. Because it'll be humid and doesn't cool off as readily, partly cloudy. And then tomorrow, partly sunny, temperatures in the mid to upper 80s, but there is a chance of some afternoon and evening thunderstorms. In fact, you'll see that on Future Look. We'll put Future Look in motion, and you can see our numbers climbing into the low 80s today with sunshine. Tonight, as we fall into the 60s, there will be a little more cloud cover. And then for tomorrow, temperatures will climb into the mid to upper 80s, and there's a chance of a couple of thunder showers working through. It may very well be that they don't hit until the evening or at night, but we have to leave room for a couple of thunderstorms possible tomorrow afternoon, and a couple of downpours are possible. And that will take us into Wednesday morning. Wednesday morning will feature some showers, maybe a rumble of thunder, but then drier weather, it looks like, by Wednesday afternoon, with our next chance of showers after that coming Thursday. So for today, we're going to see temperatures under sunshine in the low 80s, light winds tonight, partly cloudy skies, numbers down into the 60s. And then for tomorrow, partly sunny, 87 with some afternoon thunderstorms possible, but a better chance in the evening. And taking a look at the 7-day forecast, you'll see we have a thunderstorm icon in there, but notice the temperatures aren't changing a whole lot. There's no big cold fronts moving through or any, because the weather pattern is kind of blocked up for a bit. Our next cold front actually will move through on Friday with some showers and thunderstorms, leading to a dry, very comfortable Saturday and Sunday with temperatures back in the upper 70s with a chance of a quick shower. So that's how the next 7 days look. Now, that is a look at how the weather acts on planet Earth. Lauren, I believe, is going to be talking about how on our sun, and of course it affects our weather daily, but it also can have other effects in that the sun can produce northern lights. We're going to talk about that. The Aurora Borealis, I believe, coming up next. So I believe it was 2 years ago, and it was around this time of the year, we had a spectacular opportunity of witnessing the northern lights right here at our latitude here in western New York. It was incredible. We had some beautiful shots of the northern lights. And if you've never seen the northern lights, they're really, really something to behold. And we've had some recent opportunities, and we might have some more in the weeks and months ahead. But to learn a little bit more about what causes the northern lights and what they're all about, Lauren has got some answers. Hey, Lauren.
Hey, Patrick. Yeah, I believe you are correct. I do think it was May 2024 when we had that pretty strong geomagnetic storm. I'll talk a little bit more about geomagnetic storms, but typically those are what provide the conditions that make it possible for us to see the northern lights, also the Aurora Borealis. And that is not the only kind of spectacular light show that there is on Earth. Obviously, us living in the northern hemisphere, that's the one that we know, but there is also the southern lights for those in the southern hemisphere called the Aurora Australis. And again, it comes from the Latin, borealis is northern, australis is southern. But a lot of this has to do with our atmosphere. So I've spoken a bit about our atmosphere before. I'm not going to get too into it, but we have the troposphere, stratosphere, mesosphere, and thermosphere. The thermosphere is actually where the aurora, or the events that cause the light display that is the aurora, is taking place. But what actually allows it to happen is the magnetosphere. Yeah, there's another kind of sphere that it's not necessarily making up our atmosphere. In fact, it protects us a lot from solar wind. Obviously, the sun is a star. It is constantly combusting and just producing a lot of very dangerous particles for us. And the magnetosphere actually protects us. It kind of deflects a lot of that. So we are able to live on planet Earth because of the magnetosphere. I know I have it looking pretty symmetrical right now. It actually has more of a comet-like shape where the magnetosphere gets compressed on the end that is receiving the solar wind, and then it's kind of pulled on the area that's on the opposite of the solar wind, but it looked really ugly on the graphic, so I just made it symmetrical because it was prettier that way. So obviously the solar wind is kind of always happening. The star that is our sun is always very active, but sometimes it is particularly active in the cases where you have a solar flare or a CME, which is a coronal mass ejection. Basically, that is when the sun is producing even more charged particles that are headed toward us, headed toward Earth, and they are going to interact with our magnetosphere, and that can sometimes cause a geomagnetic storm, which can then lead to the Aurora Borealis. I'm trying to advance my graphic, and it's not working. There we go. Okay, so sorry about that. So returning back to this graphic, when there is a particularly strong solar flare or coronal mass ejection, those charged particles interact with the magnetosphere, and they do kind of get pulled toward the poles. It's called the magnetosphere because of the magnetic pole of our two poles. So it does go to both the north and the south pole. That's why we have the northern lights and the southern lights, and that interaction creates a geomagnetic storm, which can sometimes interact with technology. But what I'm talking about right now is that it can also create the Aurora Borealis. So a geomagnetic storm, it can have various different strengths, a G1 all the way through a G5. Anything that's a G1 or a G2 not necessarily of interest to us. The impacts on technology aren't going to be too strong, and it's not going to make the aurora strong enough for us to be able to see it here in New York. Maybe if you went further north into Canada, you could see it, but that's really not too much of interest to us. Once you get to a G3, then it becomes a little bit possible. We could see the aurora depending on how strong it does end up being, because these geomagnetic storms are based off of how strong that coronal mass ejection or that solar flare is by the time it actually gets to us. We can observe something that's coming off of the sun, but it's really about how it does interact with Earth and our magnetosphere. Once you get to a G4, that's when we're actually looking at a really good potential to possibly see the northern lights where we are, and then a G5, those are extreme. That is when it can reach as far south as Florida, seeing the northern lights. So it obviously varies, and with those varying intensities, it also varies how frequent they are. These are the number of days where we could have storms of these various different magnitudes within one solar cycle. A solar cycle is about 11 years. So 4 days out of 11 years is when we could possibly have a G5 level geomagnetic storm. 60 for the G4, 130 for the G3, 360 for the G2, and 900 for the G1. So obviously, stronger it is, the less likely it is. So our atmosphere, what actually creates the aurora borealis? Our atmosphere is about 99% nitrogen and oxygen. And these atoms, these molecules, play a huge role in how we can see the aurora borealis. So I'm going to take an oxygen atom. So that has the atomic number of oxygen is 8, which means it has 8 protons, and usually when it has no charge, that means it will have 8 electrons. So you have 2 electrons that fully fill out its inner electron shell, and then it has 6 valence electrons that are then, it's not a full electron shell, you need 8 for a full valence electron shell, but oxygen has 6. That's not as relevant. So when there is a geomagnetic storm, you have all of these charged particles, you have these protons and electrons kind of interacting with these atoms, and they will create an excited state. So an electron, typically one of the valence electrons, will jump states. It will go from its ground state, where it's closer to the nucleus, where it is its most stable, and it's going to jump farther away. And then it starts to become unstable. Eventually, the electron will return, but when it does that, it releases kind of a photon of energy, which causes the color of the aurora. But what color of the aurora? I feel like everyone has their idea of what the aurora looks like. It can appear as different colors, all within the visible light spectrum. So let's talk about that. What affects the color? So it is affected by what gas is interacting, or what gas is getting excited, whether it's oxygen or nitrogen, and where it is in our atmosphere. I said this is all in the thermosphere, but even the respective altitude within the thermosphere does matter. So green. This is the most common color of the aurora for several reasons. One of them is actually just because I learned this when I was researching this. Green is the color within the spectrum that our eyes are best at perceiving. So we are just the best at picking up green. Green is caused when oxygen is excited, it interacts with those charged particles, it jumps state. So this is an oxygen one, and it's about 100 to 200 kilometers in altitude. However, oxygen can also produce a red aurora, but that is going to be at a much higher altitude, anything above 200 kilometers. Now, why would oxygen be green at one altitude and red at another? So once you start to get to that 200 kilometer altitude, the air is a lot thinner. It's already pretty thin in the thermosphere, but the higher you go with altitude, the more thin it is. So you need a stronger geomagnetic storm. You need more particles to increase the chances of even interacting with these oxygen atoms. And then once they are there, because there are so few other atoms around it, it's not colliding with other atoms. Typically when they collide, that's when they are going to release that energy and kind of restore that state. And green is the most common for when it does that. But with the longer wavelength of red, it needs more time without colliding with any other particle before it returns to its ground state, before that electron returns back down to its home shell within the atom. And so that is how you can get that red. So you need a stronger storm for that. Green is kind of the most common. Then there's also blue, which is when you have nitrogen interacting with those charged particles, and that also exists generally in that 100 to 200 kilometer range. This is the color that nitrogen would typically be, and it also requires a stronger storm because oxygen doesn't need as much energy for those electrons to jump that state in order to produce that photon of light, that colorful light. So you need a stronger storm for nitrogen to kind of get in on the fun. And then nitrogen can also produce pink. However, this is only when it is below 100 kilometers. So you need a stronger storm for those particles to get that low into the thermosphere. And then, of course, you can always get a medley of the colors, and that can produce things that look like you're almost getting yellow or other purples. And it can be really beautiful if you have a particularly strong storm or just depending on where you are geographically. I thought the aurora would be kind of a fun thing to talk about because I already did rainbows, but it is Pride Month, and I feel like this is kind of the closest that we can get to that. I think it's fascinating. I'm no, astrophysicist, but I love it. I've never seen them myself, but hopefully we'll get a strong enough geomagnetic storm at some point so that I can see them because it seems gorgeous.
Hey, one thing you should look up. There was a famous geomagnetic storm in 1859. It was called the Carrington event. Look it up. It was something that completely shut down the telegraph grid. If it were to happen today, something that strong, it would probably shut down our power grids all over the planet because it was so strong. Something that happened many, many years ago. Anyway, all right, we'll be right back with a wrap up of your forecast for this second week of summer.
Welcome back. Patrick, you were talking a lot about, that strong ridge in the jet stream and how that's creating a lot of heat, especially into Canada and the middle portion of the country. And that has me thinking about the World Cup, which is starting on Thursday. I'll dive in a little bit more into the climatology across our country, but I know there are some stadiums that are going to be playing in Texas, and I'm just curious how that heat is going to be affecting maybe some of the players, and I'll dive way more into that when we return to Beyond the Forecast on Wednesday.
Oh, that is a very good topic. Also, I'm curious about playing soccer in Mexico City with such a high altitude, nearly 8,000 feet, very thin air. Anyway, we'll dive into all of this next time we meet on Beyond the Forecast. See you Wednesday.